Hi, Kinesiology 3010. Welcome to our third part of our inferential statistics chapter. We're going to talk through today on choosing the correct test and kind of the steps behind choosing your statistical test based on your research design or based on your hypothesis. Okay, so we start off by creating our hypothesis, and we have to select an appropriate test that corresponds with our hypothesis. So if we're looking for a relationship, we need to use a correlation. If we're looking for a comparison between two groups, we need to use a version of a t-test, and so on and so forth. 3 groups use an ANOVA. And then we need to establish our significance level. Remember, we establish it as 0.05 in the realm of kinesiology. We have to determine our degrees of freedom. So these are the variable or the terms available to change. We'll get into that in a second. And then calculate our t-test or our correlation, calculate our statistic, and then compare our statistic to our tabled value of significance. So we need to use this value to tell us if we have a significant test or if that our results are larger than our chance of error, if our p-value or probability is below the alpha level. So how do we select an appropriate t-test? If we have 2 groups that are independent of each other, so all of the participants in group A and all of the participants in group B are different participants, we have independent groups. So they're not influential on each other. The 2 groups aren't going to influence each other at all. So think about this as an experimental group versus a control group, men versus women, students A versus students B, right half of the class, left half of the class. They're not the same participants, they're not the same groups, they're independent of each other. If the 2 groups are not independent of each other, we have to use a dependent t-test. So this could be repeated measures, so pre-test, post-test, or if they're paired based on certain characteristics, we have to use a dependent t-test, which takes into account the influence of those 2 groups being dependent on each other or influencing each other. Okay, then we set our significance level. We will set our significance level at 5%, where we have a 5% chance of a type 1 error, so an alpha level of 0.05. Okay, this is what we're going to use in kinesiology, and it's what we'll use in this class. Okay, then we determine our degrees of freedom. Okay, so the degrees of freedom is the number of scores in a sample that are free to vary, or the number of cases minus 1 will give us the estimated population degrees of freedom rather than the individual sample. So we give us a little bit of leeway there. So the number of cases or the number of participants per group minus 1. Okay, for an independent t-test, our formula is the mean of group 1 minus the mean of group 2 minus, or all minus the population mean minus the population of 1 minus the population mean of 2, all divided by our standard error, standard error of the difference. Okay, this is our standard error of the difference, which tells us is the difference between our means different than the difference of the population, taking into account error or chance of error. Okay, then we compare that computed t-value against the tabled t-value. So we're trying to find out if our t-statistic is telling us that we are able to reject the null hypothesis. Are those 2 different enough? Okay, so is that difference greater enough compared to the population to tell us that, hey, we have a significant difference between groups, or that difference is great enough to say that we have a below 0.05 alpha level or less than 5% chance of making a type 1 error. Okay, so how we do this, we take our t value from the table based on our degrees of freedom, and if our t statistic is greater in magnitude than that value, we can say there is a significant difference. So the absolute value of our calculated t statistic, or t calculated, has to be greater than the absolute value of the tabled t statistic, or the t statistic based on that alpha level. That will tell us that we are furthest enough different, or they're different enough to say there is a significant difference, that we believe that difference is there, and we believe that we are 95% confident that that difference is real. And what about with correlation testing? Okay, we will first choose the appropriate test, the correlation, establish our significance level, determine our degrees of freedom, calculate our correlation statistic, and compare it to our tabled t value, or tabled r value. So it's a very similar situation with t value compared to the r value, or the t statistic compared to the r. We're using the same steps of using our test and going through the steps to determine if we have a significant statistic. Okay, we would compute our r value using our r equation, and then we would compare it based on the degrees of freedom to the r value that is in the table based on the alpha level. So the greater degrees of freedom, the lower the r value is necessary to determine a significant r value. So this is our table. This is an example piece of our table here for the r value. Okay. So when we use other software like SPSS, we're not going to use SPSS for this digital version. We'll work through it with the table. But if the p-value is less than the alpha level, we can reject the null hypothesis, or say that we have a significant correlation or significant difference. If the p-value is greater than the alpha level, then we fail to reject the null hypothesis. That's the wording we have to use. Fail to reject the null hypothesis. That means we have no significant statistic in this case. Okay, so if we use software, we can determine, hey, I want to know if there's a correlation between wall volley 1 and wall volley 2, my two tests. My n is 24, so I have 24 participants. And my Pearson correlation, this is how we would read it in an SPSS output. Our correlation is 0.908, and the significance value, or the p-value, is right here with our significance value, 0.000. So it's less than 0.000, which tells us that there is a significant correlation in this case, because the p-value is less than our alpha level, and SPSS will also automatically let us know by indicating a star next to those correlations. So that's another example of how we can read the correlations in SPSS, or the statistical software that we could use. You may come in contact with it later on in your education. Okay, but how we would read this is the Pearson correlation between wall volley 1 and wall volley 2. It's a matrix here. Wall volley 1, wall volley 2. The correlation is 0.908. The significance value, or the p-value, think of sig as p-value, the actual calculated p-value is 0.000, and so on until it's actual. SPSS only gives us up to 3 decimal points. And then our n, or our population total, or the amount of scores or amount of participants, is 24. That's how we would read that correlation, between the correlation between wall volley 1 and wall volley 2. All right, I'll see you next time for our next lecture, our part 4 lecture on inferential statistics.